Hello, we are discussing about GATE 2003 ECE paper. Find the gain margin and phase margin of a feedback system whose GH is given as open loop transfer function is S by S plus 100 whole cube. What are the right values of phase margin and gain margin? Okay. First we will define the gain margin and phase margin. Okay. So before going for the gain margin and phase margin, okay, we will write the transfer function magnitude as well as phase angle. So magnitude of GH can be written as, if you are replacing with S with j omega, here also S with j omega. Okay, then you can write the phase angle as, this is a single zero, that is 0 present at origin, that will give 90 degrees. Because it doesn't have any real part, you can write it as 0 plus j omega. Phase angle is nothing but tan inverse, imaginary by real. Imaginary is omega, real is 0. Something by 0 is infinite, tan inverse infinite is 90. And since it is in numerator, you will get it as plus. Plus 90 minus 3 times of tan inverse omega by 100. This is what phase angle. And next we will go for the magnitude. Magnitude of GH is equal to omega divided by, okay, square root of omega square plus 100 square whole cube. So you can write it as omega divided by omega square plus 100 square into 3 by 2. This is what magnitude. Now we will write, okay, gain margin. Gain margin is defined as reciprocal of magnitude of GH at phase crossover frequency omega PC, and phase margin is 180 degrees plus pi. Okay, and this pi is going to be measured at omega is equal to omega GC, gain crossover frequency. So first of all we will go for the gain margin. Omega PC at omega is equal to omega PC. Okay, omega PC means phase crossover frequency. Omega PC means phase crossover frequency. Crossover frequency at omega is equal to omega PC. Angle of GH is equal to 180 degrees. Angle of GH is equal to 180 degrees. So now we will go to calculate. This is the already angle condition we know. Simply you are going to replace this angle as 180 degrees when you are replacing omega with omega PC. So write that one, 180 degrees at omega is equal to omega PC is equal to 90 minus 3 times of tan inverse omega PC divided by 100. So 180 minus 90. So 90 is equal to minus 3 tan inverse omega PC by 100. Okay, so this is minus 30 is equal to tan inverse omega PC by 100. You will get omega PC as negative value. Okay, tan inverse of minus 30, that you can write it as minus tan 30. So you will get some negative value. Omega PC cannot be negative. Cannot be negative. So you cannot calculate gain margin. Gain margin cannot be calculated for this one. Cannot be calculated since phase crossover frequency is negative. And now come for this one, phase margin. Phase margin is 180 plus pi. Pi is nothing but pi is calculated, that is phase angle at omega is equal to gain crossover frequency. Omega GC means gain GC, omega GC, gain crossover frequency. Crossover frequency. So at omega is equal to omega GC, gain crossover frequency is where the magnitude is going to be equal to 1. Already we know the equation for magnitude. Okay, so simply replace omega with omega GC and equate that magnitude to 1. So you are replacing equate magnitude equal to 1 and you are replacing omega with omega GC. So omega GC divided by omega GC square plus 100 square to the power of 3 by 2. So you can write it as omega PC omega GC, sorry, gain crossover frequency, omega GC, this omega GC square plus 100 square into root of 3 by 2 is equal to omega GC. Take square root on both sides so that it will be equal to omega GC square plus 100 square to the power of 3. Take square root, then it will be equal to omega GC square. Okay, you cannot have a positive value. You cannot have a positive value which satisfies this equation. For any positive value, remember this one, for any positive value of omega GC, the above equation is not satisfied. Equation is not satisfied. That means you don't have a value for omega GC which satisfies this equation. Okay. So since omega GC cannot be found in positive values, we cannot able to find. We cannot find phase margin. Cannot find phase margin. So we cannot calculate gain margin. We cannot calculate phase margin. So here 0 decibels is a specific value. 0 degrees is also a specific value. Here also a specific particular values. So these cannot be the right answers because we cannot able to calculate. The only possibility, even though this is wrong, okay, the only possibility that may be right is B, the option B. Option B is the right answer for this one. Okay, thank you.